Smart on FHIR and I2B2 information for the CajunCodeFest, and thanking Dr. Henry Chu and Andrea for their partnership in that regard. Also, we have Dr. Kavi Wagalikar from Harvard on the line, and would like to thank him for offering his time and expertise. So a little bit about what this organization, how this partnership came about. ReachNet is a partner with CajunCodeFest on this work, and ReachNet is basically a collaborative in its own right, and that collaborative consists of several major health systems in the Gulf area. That includes Ochsner, Tulane, Partnership for Achieving Total Health, which is the Greater New Orleans Health Information Exchange, which is basically the New Orleans safety net, major hospitals and clinics. LSU Health, which has legacy data from the 10 public hospitals, Pennington Biomedical Research Center, and then Baylor Scott and White Health in Texas. So in terms of ReachNet's capacity for patient data, there's quite a bit of clinical data, I think somewhere around 2 million patient lives. And ReachNet has established these partners for informatics development as well. Some of these partners include I2B2, which is the underlying technology for the data warehouse that is used to store the data. So I can share that there is quite a big following in I2B2. This was started in Harvard. It is funded by the NIH, and it's quite a powerful data warehousing tool that I don't want to go into too much, but certainly would want to let you all know is a part of this technology and a partner of ReachNet's. And then of course we have Smart Health IT, which is a movement to create reusable applications. So much like we think about being able to have an application that can work on several different smartphones, we would like to see applications work on several different electronic health record systems, or on several different instances of data warehouses such as I2B2. We're also working with Persistent Systems, which is a pretty large, about 9,000 employee international corporation that works on a lot of this technology solutions architecture. And then of course we have the Informatics Research Institute, which is y'all. So with that, I think we can discuss a little bit more about where did ReachNet come from? What is this all about? So we really are a product of the Patient-Centered Outcomes Research Institute. Now, what the Patient-Centered Outcomes Research Institute has been able to do is utilize excise funds from the premium payments that are being given to the Centers for Medicaid and Medicare at the federal government level, to create a trust fund, and this is a fairly large trust fund of about, I think there's about $3 billion remaining to be distributed by 2019, and it's a non-for-profit that was enacted by legislation for the purposes of really integrating what they're calling comparative effectiveness research into clinical care settings, so that pragmatic trials can be implemented. Now, what does that mean? It basically means, and I can give you one of the studies right now, is they're looking into the difference between regular aspirin and baby aspirin. So they're going and recruiting about 10,000 patients and being able to see, what is the efficacy for being able to take one dose versus the other for, say a male versus a female, or some sort of age group. And the way that they're doing this, and the way that they've done this, is by creating these clinical data research networks. There's about 13 of them now. We're in phase 2, and so if you can see here who's making up this national network of really, in some ways, kind of data warehouses that are able to enable that type of recruitment of patients to do comparative effectiveness research. You have Oregon, Chicago, Kansas, Kaiser, LPHI, which is the coordinating center for ReachNet here in New Orleans, Vanderbilt, Children's Hospital, Philadelphia, Cornell, Florida, Mayo Clinic, Harvard, Pittsburgh, California. So there's quite a few large scale organizations here, and this is important in part because we're able to do a lot of really interesting things as a result of this partnership and these activities. One of them is around the standardization of data. So what we have is ReachNet has created, PCORnet has created, with ReachNet's and the other clinical data research networks' help and assistance and collaboration, has created a way of being able to understand and standardize and harmonize data across all of these different entities. So why is that important? It's certainly because, well, if we think about a field like tobacco, or if we think about a field, such as patient ID or condition, there's several different ways to describe these different values. And so what's important about this documentation and about this movement is that it actually gets into the specifications of what exactly the data ought to look like in order to be compliant with the PCORnet Common Data Model. Now, that's of course important, because then, as developers and as scientists, we're able to know what data is available and be sure that data would exist irrespective of the data warehouse that it's on, so long as they're adopting this data model. It's getting tons and tons of utilization already, even though it's not more than a year old, really. It's moving quite quickly. How does that tie into Smart on FHIR and really what we're trying to get the CajunCodeFest to precipitate these powerful applications on Smart on FHIR? It's allowing us to go and use this API technology to sit on top of that standardized data model, and you can actually pull and these different resources. You can see that this is FHIR is an HL7 technology. This is the list of the different resources that are available. Resources are, one of the technologists that I speak with is, draws analogy to APIs in general. Kind of viewing these as individual, APIs, but there's many different ways to look at that. But essentially, these resources are attached to the information that exists here in the PCORnet Common Data Model. That is, of course, stored in a I2B2 data warehouse. Now, of course, that data storage can also exist in electronic health record systems. So it's certainly not anything to say that it only can be used for research purposes. In fact, in many cases, it will be used for clinical care. So we think it's a really valuable skill set in terms of the power of being able to build applications on so many different data sources, whether it be at ReachNet or the several different instances across the country. Now, if we take FHIR as these resources, how does it become smart? Where do we have Smart on FHIR? The way I like to look at Smart on FHIR is really thinking of it more as an SDK that sits on top of an API. It really allows for developers to be able to build applications using very common coding languages. So there's a lot of JavaScript that people use in building these applications, and that allows for kind of leveraging of skill sets that already exist. And with that, we have some videos that we think will be helpful in further clarifying the value of this technology. So if I could just see about playing one of them. Just give me one moment.
Welcome to Connect Athon. The theme of this Connect-a-thon is diabetes. ReachNet has provided all CajunCodeFest participants with diabetes patient data, which includes demographics, patient health condition details, observations, and medical statements. Now this patient data is provided over the APIs to the participants so that they can come up with innovative apps. There are 5 APIs that return various data about these patients. The first one that we will talk about is Patient ID API that returns a list of patient IDs. Second API is Patient Details, which returns details of a specific patient using its patient ID, example date of birth, gender, etc. After Patient Details API, we have Observation API, which gives the lab records of a particular patient using its patient ID. The next one is the Condition API, by which a list of diagnosis or conditions of a particular patient can be obtained through its patient ID. The last API is Medication Statement API, which gives the medication statements of a particular patient. A medication statement may indicate that the patient may be taking the medication now, or has taken some medication in the past or will be taking in the future. All these APIs are standardized by FHIR. FHIR, Fast Health Interoperability Resources, is designed to enable information exchange to support the provision of healthcare in a wide variety of settings. The specification builds on and adapts modern and widely used RESTful practices to enable the provision of integrated healthcare across a wide range of teams and organizations. All these standards that are used in the API can be referenced at hl7.org/FHIR on the home page under Resource List. Let us look at a resource patient that is provided on the HL7 website. So we open hl7.org/FHIR. Now we see this link resource, and on clicking it we get a list of resources as we can see on this page. We will open this link that says patient to get the details of the resource called patient. On scrolling down we can see the structure of the resource. This can be viewed in different formats, but as our API returns response in XML format, so the XML format is of importance to us. We will cover what tags are important and what these tags return in a later section. All these APIs are not available for everyone to access. An authorization token is needed to retrieve data from these APIs. An authorization token will be provided to all the CajunCodeFest participants for accessing these APIs. In this part we looked at the background and basic introduction to Connect-a-thon APIs. In the upcoming video, we will look at how to use these APIs with help of REST client. Thank you. Welcome to Connect-a-thon.
So that video is just again kind of recapturing the information that it was trying to present in the introduction. We have, of course, we've explained a little bit about the CajunCodeFest and how it is that you're able to get the data information. And so we do have Smart on FHIR directions that are here on the website, as well as the form that can be used in order to get a token. And I know Sonia and Andrea, Henry and Raja are all kind of working with us on that as well. But of course, I think the meat of this is, well, how do we get access to the data? And we really spent some time trying to consolidate information, actually writing out a script to try to go step by step. But there's also the Smart on FHIR directions here. Well, it looks like it might be a broken link, but very easily fixed. We have a very nice document that we are able to share with y'all, and it goes through the step by step, and of course this is also being recorded and will be posted. But if I can move on to the second video, which really details access instructions, then we just one moment.
Now we will try and access these APIs and see what they return using a REST API client of Google Chrome called Postman. First, get Postman installed on your system. Go to Google Chrome Web Store and type Postman in the search bar. The first result that we see is the one we need to install. Click on the blue button on your right that says Add to Chrome. So as we see that on clicking this button we get a pop-up telling you about what the Postman app does. Now click on Add App button. This will install the Postman app on your system. This Postman app can be launched directly by searching for it in the Start menu. Once you start the application, you will get a screen asking to log in or register. You can do that or directly proceed with the application by clicking on the Skip This option. Now that we have successfully installed the Postman app, we can proceed to retrieving data using the APIs. For any API to respond, we need to enter an authorization header that is provided to us. Now we will go to the Headers tab, under which we see these two fields, header and value. Under header, we will put the header name, that is authorization, and under the value, we will put the authorization token provided to us. Once we are done with entering the authorization header, we will move forward to hitting the APIs. Now copy the first API URL provided in the manual and paste it in the Postman app where it says enter request URL. Then make sure that the sending method is GET and press the send button. Now that we have got the response, scroll down and check if the whole list of patient IDs embedded in the XML response is displayed. The ID tag within the patient tag gives the ID of the patient. Moving on to the second URL provided to us, we will just replace the URL and append the patient ID in the end of the URL in place of patient ID. This patient ID is obtained from the previous API that gives us the entire list of patient IDs. All these tags within the table body are for displaying and creating a table in HTML. Moving down, we see the coding tag that consists of patient's race. This system tag within the coding tag refers to the URL for HL7 standard race codes, and the code value here contains the race code of the patient. Next, we see this identifier tag, which holds the patient's identifier details. Similarly, as we saw before, the system tag inside the coding tag contains the URL for the list of patient identifier codes. The code tag specifies the patient's identifier code. Let's click on this URL and see the list of possible patient identifier details as provided by FHIR. So now we can see this whole list of identifier codes and what they actually stand for. By scrolling down, we see that MR that we got in our response stands for medical record number. Moving on. Now the system tag after it, included in the identifier tag, gives the patient's medical record number, as the identifier code here is MR that stands for medical record number, and this here is patient ID. The next tag which we can see is the gender tag, which gives the patient's gender. The birth date tag below it gives the patient's date of birth, and this tag below date of birth gives the patient's deceased status. The marital status tag, which you can see below the address tag, consists of two tags, system and code. The system tag gives the URL for the HL7 marital status codes, and the code tag below it specifies the patient's marital status. The tag below the marital status tag, that is the managing organization tag, gives the organization code, that is the custodian of the patient record. This was all about the patient details API. Moving forward to the next API. Again, replacing the URL with observation/labs API. On hitting this API, we get all these lab details of the particular patient whose patient ID we have specified in the URL. The first tag under observation is the ID, which gives the patient's observation ID that consists of the patient ID followed by the observation serial number. Next we see is the text tag, which contains the display text for describing the type of observation, and the status tag below it gives the status of the result value. This is needed to track the status of individual results, as some results are finalized before the final report. Inside this code tag, the system tag provides the URI for standard observation code. Code tag gives the code of observation, and the display tag specifies the display value of the observation. Now this value quantity tag has these three tags. The first one here gives the quantity value. The next provides the URI for standard quantity codes, and the tag after it provides the quantity measuring code. After this, let's move on to the condition API, which gives a list of diagnosis/conditions of a particular patient. Now again, replacing the URL with the URL of the condition API provided in the user manual, and upon hitting the API, we get all of this patient condition data. Here in the condition tag, the ID tag provides the patient ID followed by diagnosis serial number. Here also the code tag consists of system tag and code tag, which provide the URL for disease code standards and disease code value respectively. The display tag gives the disease display name. The category tag below it also contains system and code tags. The system tag specifies the URL for the list of condition categories, whereas the code tag gives the condition category of the patient. Now let us have a look at the last API, which is the medication statement API. Copy the URL of the medication statement API from the manual and hit send. The XML response that we get gives us the following details. First, the medication statement identifier, which is the patient ID followed by serial number. The second is the patient ID for who the medication statement is, and the last one is the medication reference as to what medication was taken. And this brings us to the end of our tutorial. Thanks for watching. We hope it was helpful.
Okay, so that video was really showing about how to access the APIs themselves. One thing to note is that the header is really what we're calling a token. So when it comes time to get that string in order to be able to access the APIs, that's where the that one-page agreement and the token that Andrea is helping us with comes into play. We have actually a third video, but we were lucky to be able to get Dr. Wakalikar's time on this call, and so I wanted to actually pass this over to him if we can do that, so that he can do some describing of the actual development of applications, because of course we would want y'all to not only just access the infrastructure but actually build something. And so with that, I will try to see if I can switch this over.
Roll, do you need to change him to the presenter? Does he have some?
Yes.
Okay, no problem.
Yes, you can help. Okay, great. Great.
Hi, can you see my screen?
Yes, we can.
I can see it, yeah.
Okay. Hi. So I'm actually filling in for Josh Mandel, who is actually the architect of SMART. Let me see what's best that I can do. So SMART, as Rahul described, SMART on FHIR is kind of a very hot research topic, and not just research. It's actually FHIR is a very practical thing. A lot of development happening on FHIR, and SMART has been quite an old initiative. It started, I think, at the same time as FHIR, and but it was not based on FHIR. So what really is FHIR and what is SMART? FHIR is a set of specifications about how medical data is represented and how it is accessed. And SMART is a protocol for authenticating with FHIR servers. Now, for the competition, we have ReachNet has made a FHIR server available for 300 patients. And in FHIR, in FHIR, the way to access data is by using URLs. So because FHIR is based on REST, and the demo which you saw about accessing the FHIR endpoint, I think that was pretty clear about how to use Postman, a simple app, REST protocol to read data. So right now, the endpoints given by ReachNet is just allowing you to read data, not put data in. And I guess for the competition and for your exercises for the class, it would be good learning if you can develop an app which accesses this data and does something meaningful. That's what the competition is about. And it's good learning for you because FHIR is going to become mainstream down the line. And the way to learn FHIR is to actually start coding. So my role with ReachNet has been about developing the FHIR endpoint, and that is actually based off I2B2. I2B2 is I2B2, as Rahul described, uh, is a software for storing patient information uh, and allowing researchers to build cohorts out of from that information. So I2B2 is something which sits in parallel to the EHR, and it replicates the EHR information. But EHR allows a physician to access one patient data at a time, while I2B2 allows the researcher to query across patients and identify cohorts. So ReachNet has made a FHIR API available on top of I2B2. So you really don't need to know that there is an I2B2 server at the back end. All you really care about is the FHIR API. Now, ever since FHIR has been in development in open source in HL7, there are several servers publicly available which one can connect to and use. So this list I'll somehow make this document available to you maybe after the class, and you can see the listing of FHIR servers available throughout the world. And you can use Postman to talk to any of these servers and access resources. That's a way to learn FHIR. Next is how do you actually build apps? How can one actually build apps on top of the FHIR servers? So these are clients to do something, to get something done. For example, let's say the EHRs, all the modern day EHRs are moving towards supporting a FHIR endpoint. So if one were to do an app, let's say a mobile app, which works on a particular FHIR server, because all the other EHRs are also supporting the FHIR specification, the app should be able to be executed across hospitals. Right now, whenever you do something on an EHR, develop an app on an EHR, it's very specific. For example, Epic, it's very specific. It works on just on the Epic EHR, and all the hospitals which have got Epic may be able to run your app. But if you were to do an application using FHIR API, down the line, one should be able to execute it across all the modern EHRs which are supporting FHIR. So what goes into making an app? Okay, so an app could be anything. It could be a Java-based app. It could be a whatever language you take. It could be an application which basically communicates to the FHIR API and does something with the data. So the SMART initiative has gone a step forward, and it has provided a library which allows one to develop app using HTML, CSS, and JavaScript. You could guess that an app based off HTML and JavaScript could run on smartphones, on tablets, on PCs. So there is some sample code available out there, and the ReachNet has tried to make some sample code available for the codeathon. So it's easy for students, or for anyone. The best way to learn is to get some sample code and start modifying the code. So in the last 1 hour, I've just tried to put together some sample app, an app which I wrote last year, and hopefully that should be helpful to get you started. Okay. Do we have any questions at this point? I hope I have not lost you.
I don't think so, Kavi.
Okay.
I'm sorry. Did somebody have a question?
Yes, I do. This is Raja.
Yeah.
The question is, It's very well clearly explained. One of the question I'm asking is, for example, if we want to find out the link between the time frame, the diagnosis code is coming independent of the time, as well as lab tests also coming independent of the time. For example, if we want to find out the trend line for the particular patient over a period of time, I need the time and the connection between diagnostic, lab work, and the symptoms. If you can explain how we can get those information, that will be really helpful.
Okay. So I assume that there should be some variable of time of when that particular resource was, I mean that when that particular piece of information was available. If it is not, I think the development team will have to make that available. It might just be a bug. So hopefully down the line, maybe in the coming few weeks, they would fix that.
Okay.
Okay.
That'll be good.
So that brings up this very important point that when one creates a FHIR resource, the resource has got several elements in it, and when that resource is implemented on different FHIR servers, people may may implement those elements to varying degrees. For example, for a lab, it is just sufficient at a minimum the lab need, for the lab resource, and that's an observation resource, it needs to at least have a name, what is the code for the lab, what was the unit, and and the time the lab test was done. And there could be whole other elements in the lab resource, like who was a provider, who ordered it, and what was the encounter number, or the date of visit of the patient. So these may not be available in the resource. Okay, so when you look at the public servers, you'll find some variability as to the extent to which the elements are presented. Okay, so there is FHIR says at a minimum you need to have these elements, but you could also have these optional elements.
Okay.
Okay, it's an important point to keep in mind if you're developing an app. You need to remember that your app should be robust. If it expects a particular piece of information and it's not there on the server, your app should not crash. Yeah, so I mean that's a point. Rahul had also noted that we need to make that available, and that is missing. Because FHIR is kind of this recently, and all these implement them in their own way, and it's not heavily tested. And as students of computer science, we know that something which is not tested, it may not be very robust. So this kind of the ReachNet team would really appreciate this kind of feedback. That if you find that something which is expected is not there, you kind of write a mail to them, and they should be able to resolve that as soon as possible. Yeah. Any other question? Okay, moving ahead, I wanted to show you this library of apps. This is something which this is a smart app gallery which the team at Boston Children's has made available. Let me see if I can launch an app. So this is an example of a growth chart app. Typically, you see the static static charts in an hospital. But what this app is doing, it's taking, it's plotting the I think the weight and the height of the child, and you can compare it with the population and have a visual display. So this app is resolving one particular need of the clinician. It is talking to a FHIR backend, pulling out the data, and the IP of or the skill of the use of the developer here is to have a very rich visual display. It is a display which makes makes the app very useful here. So you can go through the app gallery and look at some of the sample apps and see, kind of learn from how they're working. Okay, and I'm trying to provide to you a very simple sample app.
Kavi,
yeah,
is there a way if you can provide the source code of this particular app, because that involve all this timeline as well as a trend, that'll be really helpful, so that we can figure out how we can pull those timeline from other data, I believe at least 300 patients data, and do something about it.
Yes. So all this data, all the code for the app gallery is available in open source. These are all open source apps. You can just navigate to the site, and there'll be links. It's in GitHub. But a note of caution over here that these apps which have been built, they were not FHIR based earlier, and now they have been migrated to FHIR, and they're not really heavily tested across different installations. So this works on the reference server of Smart on FHIR. This is different from the ReachNet server. Okay, so yeah, so that's where, when you build an app, it's good to test across different servers. Okay, so if you take this app, it may not off the shelf work across the ReachNet server, because some data point it may not be having. The ReachNet server may not be having the data which the app expects. Okay, so that code is available. I'm making a sample code, the app which I wrote, available to you. And so if you go to GitHub Vax K, there should be a repository. Okay, so here is the link for the GitHub repository. You can just take that. Let's see in real time if it actually works out. You can do git clone. Go into software tutorial, look at README. So README is installing a server, because the app needs to run in a server. So let's just try executing these steps. Okay, you can go to the local server and see how that looks. So there is a link to launch the particular sample app. Each of you are going to be getting a username and password, and when you put that in, you can log in. So now this is the OAuth authentication, in which the app is running, and the app says, app asks the clinician, okay, do you want to execute this app on the FHIR endpoint? Do you trust this app? Do you know this app? And if the physician says yes, okay, you provide the username and password, and the app gets the authorization to log, to access the server. So it's a very simple app showing things like demographics, what the labs are, what are the diagnoses. Okay. If you look at the code, patient app, go to first app 1. So there are basically just two files. One is launch.html and index.html. So launch is about, uh, so I'm trying to make it simple. You don't have to worry about the smart protocol as far as your exercise is concerned. So you can take this folder and all you need to deal with is the index.html. So this is uh, JavaScript, and you can also just take it as is and just modify this code. So just walking you through it, FHIR.OAuth to ready is executed when the OAuth dance is complete and your app gets a token and the handle to the smart smart instance, uh, and then these are the calls which are accessing particular resources. So this call is accessing the patient demographics, and then you can cycle through or step through the patient resource, and extract that piece of information and display it in your web page. This is what's happening over here. Next call is looking at conditions. This call is getting you the conditions, list of conditions, and in this code you're stepping through the conditions and displaying them in a simple list. Next call is going through observations. So you can just begin off this code, and your expertise or your skill over here is how in using HTML and CSS, how you can show this this data in a very rich way. You can hide particular information which is not relevant to your use case, the use case which your app is trying to address. For example, if you're doing an app which kind of advises the physician on what labs are necessary, you can totally ignore medications and observations and deal with the labs and see when was the last lab done, and your app could have the logic about, okay, when is the next lab necessary.
This is Jagdish. I wanted to ask something about the smart API and also the FHIR API and everything is already trapped in this somewhere or in the library, or how does that system know? Like when you say FHIR.auth2.ready.
Yes. So if you look at
where
this,
is that? Like,
yeah, let's go back. So these are the library, FHIR.
Oh, you have the library there, okay?
Yeah,
because I tried to run through the C# one of the application and tried to kind of create and access it. I was able to successfully get that through the token authorization. Everything is done. I mean, next thing I'm trying to query through the API got rejected by fatal violations.
Yeah.
So that's why I thought something especially is expecting something behind it. So I don't know what it is.
Yeah, so this is what these libraries are what what the smart team, Josh and Nikolai, they are the authors. They have made this available. The idea is to really simplify the work. You don't have to worry about the OAuth dance and getting the tokens. All you need so this is a sample app. You can use this library, and these calls are abstracting away that stuff about exchanging tokens. So you don't need to be
Probably
stuck
I
at
was
that
missing
phase.
those library. That's the reason
Yep.
I couldn't go further.
That's right. So and you'll find the same structure even in the smart app gallery. You'll find the same code over there. These FHIR.ClientJS and these libraries are the ones which are everything is based off that. And it's obviously jQuery is also there. Yeah. Any other questions? Well, you could try executing these simple steps and see if the sample app works. I have tested that it works in Chrome, it works in Safari, it doesn't work in Firefox. I don't know about Internet Explorer. probably this might be a good way for you, for your exercises, that you can think of a use case and see, examine the 300 patient data set and see if the required data is there, and code and make a uh, rich graphical interface using CSS.
Is that only going to allow the internet clients, or is it can anything like a desktop application even?
Yeah, it should. You can even write a desktop client, but then no, I don't think there is right now a library which will simplify the OAuth authentication for you.
Right.
So you may have to deal with that part first, or you could choose not to worry about the authentication and deal with the you could talk to other open FHIR servers which probably don't support the smart authentication, and you can just just as you do in Postman, do those calls. You can do those calls over there, but then you won't be able to use the ReachNet 300 patient data set, because that's kind of So if you look at the all the publicly available servers, most of them is mock patient data. It's not real. It's all fake. There are only few servers, I think Gram server and the ReachNet server, which are giving you real data, and that's why it's kind of protected with OAuth just to make sure that it's not open to the public. It's it's very well logged about who's accessing and when. So that is the only reason, having real patient data is the only reason why the ReachNet server has got this layer of authorization.
And then if I could just qualify that a little bit and saying that, really understanding the OAuth 2 is very important, just because authentication and security in health data is paramount. So it's really an opportunity in a way, because you have access to the rich real patient data, but then also have to learn how to protect or access the protections.
Yeah, so it's a good opportunity to learn, but again, it takes a while, to learn. Even for me to learn and implement the OAuth 2 authentication for FHIR easily took me, 3 to 4 weeks. So given your exercise, I mean that's the reason why I would advocate. It's good to learn and understand what's happening. But if you want to get something done, an exercise done, you could focus on the display part. And as a student, whenever we do a project, we always think, okay, what am I going to get? I'm investing this time, I'm doing this exercise. What am I going to learn from it? So what you can learn over here is the FHIR specification, because that is going to stay in. If you're looking at a career in healthcare, it's good to know that, and it's good. This would be a good start. And secondly, if you're going to do web development, or even if you're not going to do web development, it's good to have a handle over HTML, CSS, and JavaScript. Understand that. So, doing a project and developing a smart app is a good way to polish those skills. Any other questions, comments?
So I think I might not be, I may be mistaken, but I think that in order to open it up for questions with Sonia's class, they have to pass around a phone or a microphone. Would that be right?
Yeah, I did it. Can you hear me?
Yeah, we can hear you. Yes.
So basically, you need to come to my computer and speak if you have questions. I do have one question. We talk about the smart app gallery. Is there a particular address for that?
Yeah, I mean, I think it's gallery.smart. I just Googled it in front of you. I didn't remember it.
Okay.
And I can send these along through Andrea as well.
I think logistically, if we have any more questions, can we have some address, or should we just go through me or go through, how do we gonna direct this if we have any more questions from the students in connecting the server in the back end and stuff like that?
So I think that for general questions, my email address will be available. It's rjain@lphi.org. Again, that's rjain@lphi.org, and I will be able to forward that on to appropriate resources. But one thing that we can do is make available the Smart on FHIR forum, which is staffed by the Smart Health IT team, and that address is available. I can send that along as well. It is directly linked off of the smarthealthit.org website by just going to the Build Apps link and to discussion groups. It pulls up a Google group where new topics have been created.
Okay, I probably would use this resource link and post it on my Moodle site.
Sure.
I think they're being very quiet. I don't know they're too frustrated or too overwhelmed with this smart app here.
Yeah, it can be overwhelming, but that's why it's good to get some sample code and start building off it.
Okay. We have one question, just a minute.
So I have a question. The application you were showing us, the example application, was that you were saying in particular would not work on Firefox and Internet Explorer, or was it the FHIR application that doesn't work on it?
Yeah, I think this particular one, which I just tested it, doesn't work on Firefox. I don't know why.
Okay, so FHIR does work across all browsers, all web browsers.
So, that's right. So FHIR itself is a server available on a particular port, and it doesn't care what language your client is written in, whether it's a web browser, whether it's a desktop client, whether it's another server.
Okay, thank you.
Sorry, I think the answer kind of in and out. Will you repeat again, please?
I think you broke up. Can you just say that again?
I think the last 30 seconds of answer actually broke out.
Yeah. So what I was saying is the FHIR server is agnostic of what technology the client is written in. It could be, it could be Python, Ruby, Java, C. All the server understands is that it's running something on watching a particular port, and looking for XML or JSON docs, and it will parse and it will give back a reply in JSON and XML. Just like your HTTP server does not really care what technology the client is written in. Does that answer your question?
Yes, thank you.
Yes, thank you.
So FHIR is it just builds off XML. It's a specification, which describes that of a healthcare resource, you can represent using XML, using these particular elements, And these are the operations that the FHIR server should support.
One thing that might help us, Sonia, is if you all are able to mute your microphone after asking the question, because otherwise we hear ourselves talk and it's a little bit challenging.
I guess I bring the very sophisticated mic actually not working.
Oh, that's okay.
I think they've been quiet. There's no more questions here. I think when they start playing with the tokens and going on with retrieve the data, they may have more questions. I think we probably needed the blog and to go in to pose a question and get answer from some expert.
Yeah, just one more thing I wanted to add is
okay.
So the tokens, the exercise with the tokens is to is for the student to learn how how OAuth works, and what the authentication process is. But it's important to not get stuck, with the authentication and OAuth. Just the idea here, it would be good to move on and actually do something with the data. So it's only for learning, what the exercise with the tokens is just made, just to simplify what's happening in the back end. But you can actually even, student can completely ignore that and directly work on, on playing with the data. Yep, that's all that's what I wanted to say.
Okay, I think that would be it. Do you have like is the build data, you actually retrieve the data, that's the final products we're going to see after we use the FHIR to build? Or do you have any other application? Yes, to show us.
No, I think the 300 patient data set is what's going to be available for the codeathon. I think the codeathon team may probably fix some bugs and make more things available, like dates, as one of your students pointed out. They'll make some additional things available, but I don't see it changing in a big way. Hello?
Well, if there are no other questions, we can we can drop off and certainly continue to communicate via email. And if there's further needs that need to be met, we can work to fill those.
Okay, we'll do. We keep the communication open, and we'll let you know whenever we encounter some situation or problems.
That sounds great, and I hope you all are as excited as we are. It's a new technology. It's certainly it's fire. It's catching fire, and I think we are on the early side of the of the game, really. And if we are able to pick up this competency and develop mastery around it, I think we're going to be well positioned for the future.
Thank you
all. I'd like to thank everyone.
Thanks,
thank you so much.
All right, thank you.
Thank you.
Thank you. Talk to you soon.
Okay, bye.
Bye.
Bye.